So, NASA says that it shoots gas out the back of its rocket, and that propels it. Now, let's just say you drilled a hole in your gun, in the combustion chamber. Do you think that that bullet is really going to go out when you combust the thing? No. The air is going to take the path of least resistance, and instead of blowing the bullet out, that's going to take a lot of work. Why not just escape through the hole? You know, and not have to produce any work. Does it produce any work? Does gas escaping through a hole produce any work? No. The gas has to be contained. Gases don't produce work unless they're acting upon a solid body. And they can only act if it's pressurized. If there's no holes. If there's any holes, the gas will just escape without producing the work you want. Alright, so now NASA has their rockets, right? And they have their combustion chamber. Now, their combustion chamber has a hole in it. Obviously, because that's how it's going to shoot gas out the back, right? So they light the combustion chamber and the gas expands and escapes out the back. Sounds a lot like the hole in the combustion chamber in the gun. Not going to produce any work, just escapes. There's nothing that the gas is pushing on. It's escaping into nothing. Now, you can think of a balloon. You can give me a counterexample of a balloon. Well, let's say I blow up a balloon, and I blow it up as big, and then I let go, and it shoots around. So when you're letting gas flow out really fast, yeah, there is going to be a reactionary force because, yeah, that gas is contained. It is. I mean, if you think about it, the gas is contained because it's shooting into the air, and that air is providing some friction, some resistance. Okay, a resistance against that blowing air coming out. So yeah, you're going to make a little bit of a force. Yeah, the air coming out of the combustion chamber, the hole in your gun's combustion chamber is going to produce a little teeny force. You know, that's air can push against air. So, but in space, there's no relative containment on your airstream. You can shoot mass out the back. You can shoot gas out the back because that's what they're shooting. You can shoot gas out the back as fast as you want, but there's no air pressure. There's no friction to be able to relatively contain that gas to actually push you forward. And there's no air pressure or anything else to produce a reactionary force. So Newton's third law is not in effect in that case. So that's a special case. I mean, gas is a special case. You can't throw a gas. You know, if I tried to throw some air, not going to work.
And there we go. There we go. And as you can see, there we go. It's going pretty well. What I'm saying basically is that the air just coming out of the straw acts on the atmosphere that's in the room, which causes a reaction which then pushes the whole lot forward. Now, if pro-moon landers are correct in that the air moving this direction will cause an equal and opposite direction force in that direction, then it should move. Whereas if I'm correct and that it needs the mass of the atmosphere to act against, this shouldn't move, basically, okay? Because we've actually diverted the thrust force of the balloon car, okay? So we're going to now put it to the test. So here we go. Let's just line it up. Here we go. And we're off. And we're off. And we're off. It's not moving. What we're going to do, it's not working at all, and it's not moving. The balloon's going down, the air's coming out of the straw. It's hitting the straw. I can feel the air from the side, and it hasn't moved one little. What's going to happen in a vacuum when the rocket's in space, and that is the fuel is going to be pumped out. Okay, you're going to have combustion, you're going to have the thrust force coming out, okay, out of there. But there is no mass there for it to act upon. Therefore, you won't get the reaction in this direction. You will not get that because there is no mass for this thrust force to act upon. Now we've clearly demonstrated that with the balloon car in the video, but also one of the major factors of why a rocket will not work in space is that we also have the idea of free expansion. So basically, with free expansion, as soon as the valves are open to allow the fuel and the oxidizer into the combustion chamber, they'll just be sucked straight out by the vacuum of space, like this. And the rocket will just remain stationary. It won't go anywhere.
A gas will expand freely. A gas will not do work if it is open to a vacuum. If a gas is open to a vacuum, it will expand and escape while doing no work. Okay, that is joule free expansion. It's free expansion because it is expansion without work. So that means that when that gas expands into a vacuum, i.e. the rocket exhaust gases expanding into space, it cannot do work. And what is work? Work is force times distance.
Hi everyone, welcome back to Cody's Lab. So I actually have a little feather right there, as you can see, suspended in front of a 12-volt electric fan. To turn it on, I have a little tilt switch. You can see when I turn the fan on, it blows the feather all over the place. This is, of course, at atmospheric pressure right now. We're using the vacuum chamber once again, and now we're going to suck out all of the air, or at least most of it, down to the point or about between 4 to 6 millimeters of mercury, which is the pressure on the surface of Mars. There we go. These pieces of CO2 look really interesting. Cause them to levitate and float all over the place. If you can see the gauge over there, you can see that the air pressure is just about to the point where it's would be considered the surface of Mars. And let's turn on this fan. Place your bets as to what's going to happen to this feather. Now the fan's only going to produce maybe 10 miles per hour worth of wind, so let's see what happens. Okay, fan's on, and the feather's not moving. In fact, let's zoom in on that. Not even flinching. Let's turn the fan off. Okay, and let's turn it back on. So to finish up this experiment, I'm going to turn this fan back on, just like this. And now I'm going to let the air back in, and let's see what happens as we come back to Earth. Yeah, almost immediately you can see the feather start shaking around more and more violently. So there you go. The air density has a big impact on what wind velocity actually does. Hope you all enjoyed. I'll see you next time.
He's not even at full vacuum, and this fan is blowing directly on this feather. Even so, this is so much proof here. You can show anybody this, and it clearly proves rockets do not work in space. I gotta talk over this guy. He's got almost a million subs that are now, if they think outside the box and understand how rockets do not work in space. I mean, it is just... And what he does in this experiment is quite literally prove that rockets do not work in space.
So NASA picked the wrong thing. I mean, if they said that they were shooting guns out the back to get to the moon, you know what? Maybe I could believe them. You know, maybe I could, because the physics would make sense. Or maybe if they're shooting a big enough gun with a moon-sized bullet out the butt of their rocket, maybe they would get to the moon. Okay, but they're not. They're not shooting actual mass that can sustain a reactionary force. They're shooting a gas that, by definition, a gas in a vacuum cannot sustain a reactionary force. Now, how would these NASA people counter my argument? They might say, well, there is a reactionary force pushing against the inside of the nozzle of the rocket, and it's pushing the rocket forward. And like I said, you know, gas cannot produce. There can't be a reactionary force on the back of the nozzle because the gas is freely expanding out. What else? How else could they say? Oh, sometimes they say, oh, well, it produces the gases coming out the back of the nozzle. They produce a cloud. There's a cloud there, and then the latter gases, the gases later on, they push against the cloud. Oh, so you created a cloud in space. That's pretty amazing. So that's pretty much it as far as Joule's free expansion and how that relates to rockets in space. And yeah, I mean, it's another proof. It's another solid proof. It's 100%. I mean, physicists cannot argue with this. They can't. If they try to argue with it, they don't understand Joule expansion. I mean, provide them with a document. This is Joule free expansion. It says that we cannot sustain a force in a vacuum with a gas. It's just that simple. I think I covered everything. I mean, I don't know how else to